Hello everyone, you are welcome to today's class. Our topic today is how to plot a physics graph correctly. First, draw your axis. Draw two straight lines at right angles to each other. The horizontal line is called the x-axis and the vertical line is called the y-axis. Always start your axis near the bottom left corner of the graph sheet. Next, label each axis clearly. Write the physical quantity along the axis and include its unit in bracket. For example, you may write distance in centimeter, potential difference in volts, or current in amperes. Correct labeling is very important in physics graph. Now choose a suitable scale. Look at the range of values in your table. Choose a scale that spread your point over at least 2/3 of the graph paper. Avoid using awkward scales like 3, 7, 11, scales of prime numbers, and make sure your graph uses most of the available space. Using simple scales, e.g. 1 centimeter is equal to 1 unit, 2 units, or 5 units. After that, plot your point. Mark each point carefully using small, sharp crosses or neat dots, maybe inside small circles. Accuracy is key, so take your time while plotting. Once all points are plotted, draw the line of best fit or curve. Use a ruler for straight line graphs and draw a smooth curve where necessary. The line should pass through most of the points, with the points that are not on the line scattered slightly above or below it. Now give your graph a clear and descriptive title. For example, you can say graph of potential difference against current or graph of load against extension. Finally, let's find the slope of the graph. Choose two well-separated points on the line of best fit. Draw a large right-angle triangle between these points. Read the values from both axes. Use the formula slope is equal to y2 minus y1 divided by x2 minus x1, and that is it. If you follow these steps carefully, you will be able to plot neat, accurate physics graph every time. Let's apply this rule step by step using a table of experimental value, which shows pairs of applied force F in Newton and its corresponding extension E centimeter in bracket, 10.0 1.2, 20.0 3.6, 30.0 5.4, 40.0 7.2, 50.0 9.0. First, draw two axes at right angles to each other. The vertical axis or y-axis represents the applied force. Label it F. Include the unit in bracket, Newton, capital letter N in bracket. The horizontal axis or x-axis represents the extension. Label it E with the unit centimeter, cm in bracket. If you measure the grid lines with your ruler, you will notice that one large box represents 1 centimeter on both the horizontal and vertical axis. Always begin a graph at 0. The bottom left corner has 2 zeros, one for the x-axis and one for the y-axis. Now we choose a scale that allows the data to spread across most of the graph paper. Looking at the first values, we choose the scale on the f-axis such that 2 centimeters represent 10 Newton. So the marking will be 10, 20, 30, 40, and 50. For the extension values on the e-axis, we choose 1 centimeter to represent 1 centimeter of extension, marked as 1, 2, 3, 4, up to 10. Before plotting points, it's important to understand what each small square on the graph represents. Between 0 and 1 on the e-axis, there are 5 small boxes. This means that each small box represents 0.2 centimeter. So we can count as follows: 0.2, 0.4, 0.6, 0.8, 1.0, then 1.2, 1.4, 1.6, and so on. Similarly, between 0 and 10 on the f-axis, there are 10 small boxes. This means that each small box represents 1 Newton. So we can count as follows: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's now plot the values from the table. The first point is 10 Newton against 1.2 centimeter. From 1, count to 1.2 on the e-axis. Then go up to 10 on the f-axis and mark the point. The next point is 20 Newton against 3.6 centimeter. On the e-axis, count 3.2, 3.4 and 3.6 and go up to 20 on the f-axis to plot the point. Next, plot 30 Newton against 5.4 centimeter, then 40 Newton against 7.2 centimeter, and 50 Newton against 9.0 centimeter. Make sure each point is clearly marked. Now, draw a straight line of best fit through the point. The line does not need to pass through every point exactly. What matters is that most points lie on the line, and any points not on the line are evenly scattered on both sides, just like what we have here. 3 points lie on the line and 2 points slightly off, but these 2 points are on both sides of the line of best fit. Perfectly acceptable. The title of this graph will be Graph of Force Against Extension. To calculate slope, draw a large right angle triangle on the line of best fit, like this. The slope is given by slope is equal to change in f divided by change in e. That is, slope is equal to f2 minus f1 over e2 minus e1. From the graph, f2 is 39 Newton and f1 is equal to 20 Newton. E2 is equal to 7.0 centimeter and E1 is equal to 3.6 centimeter. Substituting into the formula, slope is equal to 39 minus 20 divided by 7.0 minus 3.6. That will give us 19 divided by 3.4 equal to 5.56, approximately 5.6 Newton per centimeter, since F is in Newton and E is in centimeter. And that's how to plot a force extension graph. Draw a line of best fit and calculate the slope. In our next lesson, we'll be interpreting the equation of a straight line graph. If this explanation helped you, like, share, and subscribe for more physics tutorial. See you in the next class. Bye.